Okay, for this next example, we will again solve the missing parts of this oblique triangle by the use of the law of cosines. But for this case, we are actually given two sides and an included angle. So that is SAS. Okay, so from this illustration, we are given the value of angle C, which is 49 degrees, side B, which is 5 units, and then side A, which is 7 units. So by the use of the law of cosines, we can actually solve for the missing parts. So let us solve first for side C. So solving for side C, let us use the equation C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. So by simply substituting the values, that will be equal to C is unknown, so we'll retain that as C squared. But as we know, we are given the value of A and B, which are 7 and 5. So this is 7 squared plus 5 squared minus 2AB. So we'll just multiply 7 and 5 right there. And then we have the cosine of the given angle, which is angle C. So angle C measures 49 degrees. So that is cosine of 49 degrees. Okay, so since we are solving for C, we need to find the square root of both sides of this equation so that the square will cancel out on the part of C and it will be transferred in a form of a square root on the other side. So we are actually solving for the square root of the whole of this. So by doing that, let us use a calculator to solve for the value of C. So we are trying to solve for the square root of 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of 49 degrees. So right here, we will able to solve for the value of C, which measures 5.298666, etc. But we will round this off to the nearest hundreds. So that will be 9 becomes 10. So we'll carry it out. So this will become 5.3 units. So C will be approximately equal to 5.3 units. Okay. So we're able to solve for side C, which measures 5.3 units. Now we can actually solve for the remaining parts if we know the value of this pair of opposite sides and angle. Since we know that side C measures 5.3 units, then we can actually use that as a pair, and then we can apply the law of sines to solve for the remaining parts. So let's say we're solving for angle A by the use of the law of sines. Since we already know the value of angle C, we can use sine C over the given side, which we already solved for this, which is 5.3. And then we have, of course, we're solving for angle A over side A. So by substitution, we can say that sine 49 degrees over C, which measures 5.3 units, is equal to the value of angle A, which is unknown. So we'll retain this as sine A over the value of A, which is 7 units. So this is 7. So since we're aiming for the value of angle A, we'll multiply both sides by 7 to get rid of 7 on the denominator. So we have here sine of angle A is equal to 7 times sine 49 degrees all over 5.3. Since we're solving for angle A, therefore we'll take the inverse of sine so that we'll be able to solve for angle A. So that will be sine inverse times the whole of the given, which is 7 times sine 49 degrees over 5.3. So right here, we can input the values on the calculator. So we have the sine inverse, 7 times the fraction of sine 49 degrees all over 5.3. So we have here the value of angle A, which measures 85.41 rounded off to the nearest hundreds. So A measures 85.41 degrees rounded off to the nearest hundreds. So what remains is the value of angle B, but as we know, the sum of the interior angles of a triangle is equal to 180 degrees. So solving for angle B, we'll just subtract the value of angle A, which measures 85.41 degrees, minus the value of angle C, which measures 49 degrees. 180 degrees minus 85.41 minus 49 degrees. So we'll have 45.59 degrees. Okay, so here you go. We have now the value of angle B. So right here, given two sides and an included angle, we'll be able to solve for the remaining parts of this oblique triangle by the use of the law of cosines. Thank you so much for watching and see you on the next videos.